In this video, I'm going to go through the stepwise regression problem that you had to do for this past week. And really what I want to do is go step by step on the procedures that I identified this past Monday. First of all, you can see we have a dependent variable, and we have three predictor variables or independent variables, x1, x2, x3. As you were told, the first thing that I want you to do is to do a correlation matrix. And we'll go data, get our data analysis pack up, go to correlation. And then what we're doing is that we're going to take columns A, D, down to 13, all inclusive. We're going to mark the labels, and we're going to say OK. And you can see immediately we have our matrix. And the first thing would be, okay, what about collinearity? And collinearity, if you recall, is what I mentioned about we want our independent variables, x1, x2, x3, to be independent of each other. So here, x1 and x2, we can see we have 70%, 71%. So that could be suspect right off the bat. And then x1, x3 is 58%, and then x2, x3 is 64%. So really we only have one from our demarcation of 70% that is indicating that we could have some dependency between our independent variables. The second thing was, okay, stepwise regression. We want to bring in one predictor or one independent variable at a time. We have to decide which one's going to enter the equation or the model first. And as I indicated, we will take the one that has the highest coefficient of correlation. And right off the bat, you can see y and x3 is 98.5%, x2 64, and x1 is 58%. Therefore, as indicated, the first one that'll get into the model to test is x3, and then x2, and then x1. So we'll go back to our data, go to our data analysis, and this time we'll look at our regression. We'll set the regression up, and our y. And then our x will be, of course, our x3 predictor independent variable. We'll mark our labels, and then we'll come back and we'll do the analysis, and we can see that, oh, the r square is 97%, and we can come on down here, p-value. Okay, the p-value is 5.62 to the negative 0.9. As we know, we would have to move our decimal point over 9 places. Very small p-value, which of course is less than our level of significance, and we would say yes, x3 is significant. There is a very strong relationship between y and x3, so this will be kept into the model. Going back to our data, so just kind of for the sign point, remember 97%, and I will come here and I will mark this as, I'll just say, x3. I want to go back to the data. Now I want to bring in the second independent variable, and that was x2. Make sure the labels are there. X, okay. And we would want to, first of all, we can go down here to the adjusted r square. If you recall, when we only have one predictor variable, we focus on the r square. And the r square, as you recall, is a coefficient of determination, which indicates what is being explained. We have a lot of variability. We have a lot of differences. That's going on between and among the values within our dependent variable. Well, the R square here of 97% indicates that I can explain the reason why that the values in the y in the dependent variable are changing is because of my predictor variable. So if you recall, if we go back here to x3, the R square was 97%. When I bring in x2, the adjusted R square, and that's what we do when we have more than one predictor variable, we look at the adjusted R square or the adjusted coefficient determination, and it has gone from 97% to 96%. So immediately that's saying, wait a minute, when I put another independent variable in, I would expect it to increase. I want it to get it closer to 1, but it's going down. So that's saying immediately that no, I don't think I want x2 in the model. And yes, when we go down and look at the coefficients and analyze the coefficient, you can see the p-value for x2 is 75%, which is way high in relation to our level of significance. You can see x3 is still significant. So I don't even have to go in, and I don't even have to bring in the third independent variable, because if the second independent variable doesn't get into the model, the first independent variable is definitely not going to get into the model. So the bottom line, from the standpoint of stepwise regression for this problem, x3, independent variable x3 is the only independent variable that is significant, because when I brought in x2, my adjusted R square went down. So the proverbial bottom line, when I look at the equation, it's x3. This would be the equation. Y is equal to negative 3.097 plus 0.97 x3. And that would be your best regression equation to use to forecast whatever y was all about.